Good morning, folks. This is the second lecture of week 7, and we started the subject of mechanism design and the kinematic analysis uh, in the last lecture. Here, I want to discuss the continuation of that topic, except that the joint that we are going to be looking at is what is called a revolute joint. So it's basically an arm rotating about a fixed base. And in doing so, first I create a cartoon, then I put some physics into it, then I generate the trace of or the path of a particular uh, point on that arm, show you how to create AVI file, and finally to do some kinematic plots, including customized one that you have to go through some steps to do that. Now, a revolute joint is basically restricting the 6 degrees of freedom of a arbitrary rigid body and turning it into a single one. Okay, so here is an example. This is a single degree of freedom mechanism because it can only this arm can only rotate about that hinge, and this is called a revolute joint. And in order to do that, we need to put two surfaces in contact with each other or coincident, and two axes being lined up. Okay, that makes a revolute joint. All right. So for the uh, example today, I'm going to take that fixed base there and an arm sitting on it, and it rotates at a constant angular velocity, omega radians per second. From elementary dynamics, you know what the position xy is. If this lies in the xy plane, it's a two-dimensional motion. X and y are given by r cos omega t and y equal to r sine omega t. Now, if you differentiate with respect to time, you get the velocity, and you differentiate it again, you get the components of uh, acceleration in the x and y direction. Okay. Notice that the only thing that matters here is that length r. Okay, the shape of this could have been anything you want, except that this distance from the point of interest to the axis of rotation is what comes into the picture, and that's what we're going to call r. Now, if you plot this information, so here you have the velocity, x component of velocity, y component of velocity, and notice they're both sinusoidal, and they're of course there's a phase shift in them. And if you plot the second derivatives, also you're going to get sinusoid, but there's a phase shift between them. So what we're going to do is today, the entire period, we're going to concentrate on this problem. All right.
I have to be in the assembly design in order to make this thing. This is not assembly design, so I'm going to go to mechanical design, assembly design, and now in assembly design double gears. Immediately I save this thing, so file, save management, save as desktop. I have a folder there, and that is the course, and week 3 activities, and it's activity YT43, so it's going to go there, and we say okay. So anything that I do, any part that I create, etc., are going to go into that, and any graphs or any figures that I generate are going to be saved in there, as if on the test or the midterm I have to upload all the all the parts, the product, and those files into the appropriate location that you will be told. Now, insert first part, new part in there, and that is going to be right-click properties. I'll call it base. Base. This is the instance name, and this is the part name. Okay, and double click on it. On that horizontal plane, I will draw a circle that's 1 inch, and that's just for my own information. I'll draw it so it's 1 inch diameter, roughly. Diameter 1 inch. Exit, and then pad it. That's fine. And then I'm going to insert the next part, insert the new part, and this new part is going to be called arm. and arm. And I'm going to double click on it. Right. So on a convenient plane, on that horizontal plane, once again, I will sketch something that resembles the arm that I want. So probably something like this. The actual shape of it doesn't matter that much, but this distance from the center to that tip should be 5 inches. Five, we say okay. All right, exit. And we're going to pad this. I'll use point 3 there. So all the way to the top, click on the floppy so that everything is in that folder now. And now I'm going to do the assembly. We will fix the base, which is the most natural thing to do. And then coincidence between this axis and the axis of the arm. And coincidence between this plane and that plane. And when I do this on my update, you see that it doesn't look very good because of those arrows, the direction of the arrows. All you have to do is to double click, flip one of them, and then update. That looks better. Okay. So you go all the way to the top and save everything. All right. Now we're going to go to the uh, digital markup, DMU kinematics. Get the magic wand out. Here's the magic wand. New mechanism, auto create. This goes unresolved pairs goes to 0. And this is going to be a single degree of freedom mechanism, and it has a revolution. Now, if I double click on this, I'm going to change this, make this angle driven, and make it go from 0 to 360 for visual purposes. Your best friend pops up, the mechanism can be simulated, and I can do that with command. In other words, I'm in charge, I do this. It works, good. Reset. Okay, so a couple of things I want to do, and that is I want to get the trace of this point or the path of this point when this thing turns. In order to do that, first you have to create a simulation. There is a simulation icon. See that? Simulate. Pick mechanism number 1, and then drag this thing all the way to the end, and then insert. And if you want to check it out, just uh, make this thing anything but 1, and you can play it continuously if you want. You can make it slower, etc. So you say fine. All right, good. So we did create a simulation. And why we wanted to create a simulation? Because we want to be able to compile it. And the reason I want to compile it is twofold. First of all, I can check your work easily by just replaying it, say creating a replay, and then by compiling. And then you can get the trace once you compile. So you click on it, this thing pops up. It says, I'm going to create a replay or a video clip. No, I want a replay. And then don't use one, just use something else and then play it and wait until it finishes. Notice that the replay has been created. If I double click, you can actually see that it is working. It is working. Chases, it goes in one direction. So good. So we created a replay, and the reason we did that is that we can go and now create a trace. Trace. Now look, a couple of things you should keep in mind. The point to the element to trace is that location, right? So that, for example, that let me see now. Okay. This point. If you leave uh, this line as a product, there is no problem. It's going to create a trace for you, but it's going to be a new part, and you have to save it. And when after you save it, you can bring it to the product environment. But the alternative is to say, okay, don't give me the product, but I will select the as a reference product the base. See that? As soon as you do that, it jumps from new part to the reference product. So you no longer have to save this path. It's going to be stored in here. okay? And I can check that. So we say, all right, notice that the path has been created. Now, how do you hide this thing? In fact, you can check it out. If you go and manually, for example, move this thing, you can see that it traces that path. But how do you hide this thing if you don't want to see it? It's created on a geometrical set, and you can hide it if you don't want to see it. It's there. Whereas if you don't do it like this, then it's gonna create a part called trace. You have to save it, and then you insert the existing component. You can bring it up and put it on the screen. Okay, good. Now, the next thing you want to do is to put some physics into this, and uh, if you click on the simulation with laws, which means physics, it's going to say that, you know what, you have to define something in terms of time if you're going to give me laws. You say, fine, we didn't do that. So we go on to knowledge toolbar right here, click on f of x, and if you get, this is the database for the entire product. If you can see everything that you have in here is reflected in this database. But if you're interested only in mechanism, you click on the mechanism, and there's really two things, time and the command. So if you select the command and you say add a formula, it says the angle equal to, remember, this is going to be uh, 2 pi, 2 pi or omega t, okay, omega t, uh, uh, r, let me see now, r omega t. So it's going to be, uh, see now, not r omega t. I'm sorry, this is the angle. So it's going to be omega t. Omega is 2 pi. Omega is 2 pi. Let me see what the statement of the problem was. Omega is 2 pi, so that's going to be, I can put 2 pi rad per second, or I can say 360 degrees per second. It doesn't matter. So I can, let me do it the following way. 360 DEG underscore S times time, omega t, right? And time is right here. Either you type this whole thing, you type it right there, or left double click on it, and you say okay. And we've done it here. There is a law that we have specified right there. And of course, you can reach this thing if you double click it again, and you can make changes, etc. Now, what I'm going to do is to create some speed and acceleration sensor, because at the end of the day, I want to plot the velocity of this point, x component of velocity and y component of velocity as a function of time. Okay, so I'm going to create a sensor, speed acceleration sensor. It says the reference product is the base, and the point is going to be this point. Okay, you say okay. So a sensor has been created here, right there. And now we're gonna go to simulation with laws. How many seconds? Let's go. Let's do it 2 seconds. Which means this goes twice. You say fine. And activate sensor. There's two things I want to do. I want the x linear speed, that means x component of the velocity, and the y linear speed to be generated. Now, keep in mind, z linear speed is 0 because this thing doesn't go up and down. Now, move this thing out of the way. See, these both no's are turned into yes, so they're going to be generated. You play this, goes twice, and then you bring it up and you say graphics. So this is, zoom out so you can see, the x-axis is x component of the speed, or y component of speed. See, the yellow one is the x component of the speed. The green one is y component of speed. Notice the sinusoidal. That doesn't surprise us because I wrote it here for you. Now, the other thing is that I want to see this on your midterm. Excuse me. On your midterm or your final, if you're asked to generate this thing, first of all, generate only these things. Don't generate 60 plots because you don't know what I'm asking for. And then you have to screen capture it, because there's no way for me to know that you have done this thing unless you screen capture it. So let me do a My keyboard is function, print screen, and it allows you to capture this. Okay. And then I start a Word document, a blank one, and paste it, and write some comment if needed. So this is X and Y components of speed or velocity if you want, and save it, file, save as in that same folder that you're going to keep your stuff to be uploaded for marking purposes on a test or a final, which was here. For me, it was week 3 activities. It was in this folder. Okay, let's check it out. So we go here, check these out. Activities. You have the product, you have the arm and the base, and you have this Word document that I have here. Good. Now, there's something else that I want you to do, and that is to, this is generated, great, but I want, these are versus time. I want one versus the other one. So I close that, and then you go to options, customize, not versus time, customize, add. It says, what do you want against what? I want X linear speed against Y linear speed. And I say, okay, and I select it, close, and graphics. There we are. So that doesn't surprise you because X dot and Y dot, if you square them, add them, you're going to get the equation of a circle. X dot squared plus Y dot squared is equal to R squared omega squared. And that means that the radius of this circle better be R times omega. R is 5, omega is 2 pi, so that's 10 pi, which is roughly 30, 31. That's good. Now, do not forget, please, to capture, do the print screen, F, print screen, get this. Go to that Word document or a separate Word document. That's it. But these are versus time, by the way. But the next one is going to be X component of speed or velocity versus Y component of velocity. Let me make these velocities because notice that they can be negative. Speed is always positive. Okay, that's good. And then save and close. So once you close these things, it's all gone. There's no way for me to know whether you have done it or not. The only way for me is to go to that folder and find out whether you have actually managed to screen capture those things. So let me save this thing and remember the trace is still here. If I want to check your work, I say, show me the trace. It will do that. That's pretty much it. Good luck.